Hello, today we'd like to look at homework questions together on the topic of inequality. We'll be looking at mostly on fractional inequalities. So first one, we have 2 minus x over x plus 1 has to be greater than or equal to 0. So how are we going to do it? In fact, whenever you have a fraction, the numerator and denominator, each one of them get to the boundaries of the interval. Top because the fraction can be equal to 0, bottom because fraction can be undefined. So when you look into the top, here we get 2 minus x is equal to 0. That means x has to be equal to 2. Bottom, x plus 1 is equal to 0. That means x is equal to negative 1. So I have negative 1 and then 2. Those are the two values that sets the or separates the intervals, quite possibly. So let's try to select the value in each case, and then we're going to test it up on the original inequality. So here, what if you let x equals negative 2, for example? Then the numerator becomes positive, while the denominator is negative. Now, so positive over negative becomes negative. What I'm looking for, something greater than 0. So therefore, this wouldn't work. In between, what if I want to plug in x equals 0? Then we get 2 minus 0, which is 2. Denominator 0 plus 1 becomes 1. So 2 over 1, which is equal to 2. Yes, that's greater than 0. So the middle section is okay. How about the rightmost section? We have, what if we let x equals 3? And the numerator becomes negative 2 minus 3, while the denominator is positive. Once again, negative over positive will make the entire value into negative. While what I'm looking for is something greater than 0. So therefore, this will not work either. So only possible values are from here to here. Let's look at 2 for a second. Can I plug in 2? Yes, if I were to plug in 2, then my fraction will be equal to 0, and then that is accepted. So in this case, I'm going to have closed the circle. On the other hand, left-hand side, if I were to plug in negative 1, you will realize that my fraction will not be defined. Therefore, it cannot be equal to 0, nor greater. So therefore, this will be open circle on the left side. And that will be our answer for the first one. How about for the second one? In this case, what are we going to do? We're going to try to combine them together and then make that into one fraction and follow the same procedure as to the last question. Since our common denominator was or is x squared minus 1, then here we get 4 times x plus 1, and here we get minus x minus 1 times 2x minus 1 has to be less than 0. Let's look at that one more time. Denominator is x squared minus 1. How about the numerator? We have 4x plus 4. And then here, minus, we end up getting 2x squared. And outside we get negative x. And another negative 2x, so minus 3x. And lastly, it becomes plus 1. If I were to combine the numerator, I get negative 2x squared and then plus 7x, and I'll be getting plus 3, all divided by x squared minus 1 has to be less than 0. So let's try to get a couple of things together here. First, making the numerator equal to 0. Negative 2x squared plus 7x plus 3. That means x has to be equal to negative 7 plus or minus square root of 7 squared, which is 49, minus 4 times, this one becomes negative 2 times 3, which is over here, all over negative 4. That means negative sign cancels out, becomes simply 7. And negative sign affects positive and negative into negative and positive, which will be basically the same thing. Here we get positive, negative, negative becomes positive. So 49 plus 24, which is 74, all over 4. Alright, so those are the two values which we are looking at. Let's try to just approximate that. Approximately, as I'm getting the calculator, let's try to set the bottom equal to 0. That means, we'll just use a calculator. X squared minus 1 has to be equal to 0. That means x will be equal to plus or minus 1. So we have two values and then two values here. So here we get 7 plus, for example, square root of 74 and divided by 4, 3.9-ish. So one answer is 3.9-ish. And I can keep the same entry here. Instead of plus, we're going to have minus, and then divided by 4. Negative 0.4. So those are the two values that which we are getting with the plus or minus 1. So our number line will be, the smallest value will be negative 1, and then negative 0.4, and then it's going to be 1, and it's going to be 3.9-ish. Alright, so let us say we have 1, 2, 3, 4, 5 sections for us to test. So what if we have we can check up on each sections we want to. Pick a number from here, pick a number from here, same here, same here, and same here. Now, another way that which we can do is that what if I were to use the, how about this, pink line to represent the top. The graph of the top portion is concave down. If I were to graph it, then it would have been something like this, as you can see. That makes this portion negative, and middle portion positive, and then this portion into negative. Middle section is positive. Now I'm going to use the black one to describe here. Since this leading coefficient is positive, so we realize the parabola would have been concave up. So that makes this portion positive, and then the middle section negative, and this portion positive. Now, by looking into that, we get to realize we are looking for sections that are negative. How can we have sections that are negative? Intervals that are negative. That's quite simple. You see, whenever we have positive and negative mixed up together, there will be negative section. So that means we are looking at here. In this section we have negative, negative, it's going to be positive. But on the other end, from here to here, it's going to be, while the denominator is negative, the numerator is positive. So from here to here. And same thing here, from here to here. Because denominator is positive, while numerator is negative. So here to here. That's basically what we end up getting. We just have to check up on the endpoint. If you have to plug in a -1, you will realize that it's not going to be accepted because it's not defined, so it's going to be open circle. So is this one. If you have to plug in -0.4, you will realize that it will make the numerator equal to 0. But that's not what we're looking for. We are looking for something that's less than 0. So it's not going to be included here. So is this one. And that becomes our final answer. So if I have to rewrite it, for example, number line would have been this way. Using a maybe interval notation, our answer would be from negative infinity to negative 1, or negative 0.4, I believe it was 7 minus square root of 74. So we have 7 minus square root of 74 over 4 to 1. Or we have this value, which is 7 plus square root of 74 over 4 to infinity. So 3 intervals becomes our answer. Alright, let's move on to the next question. Here we have, you will realize that even before we begin, 3 minus x has to be always greater than or equal to 0. In other words, x has to be less than or equal to 3. That's the domain that will only satisfy the radical. So have that in our minds. So x value has to be less than or equal to 3. So let's look at the rest of them and see what happens. Once again, we have two fractions, so we're going to combine them into one. In other words, denominator can be 3x, while here we get 3 times square root of 3 minus x. On the right side, we get plus x squared. Has to be less than 0. Now, you will realize that in this case, numerator will always be positive because I have a perfect square. And then the radical, where leading the coefficient of the radical is also positive. So numerator will always be positive no matter what. How about then this fraction to be being negative, it only solely depends upon the denominator, which is 3x. So we know that 3x will be negative if x is equal to x is negative. So therefore, our final answer is, the solution for this one will be x has to be less than 0. So there will be our final answer. Alright, that's it. I'll see you later. Bye-bye.